This video is called Solving Equations with Variables on Both Sides. What if we have variables on both sides of our equal sign? How do we solve a problem like that? Well, remember our old rules of DPSing, simplifying each side. Now the new rule is to get all variables on one side and then solve. So let's try this first example. Our first step is to DPS. So I'm going to DPS. Now I have all addition. Now you'll notice I have variables on both sides. I have 6x here and 9x there. I need to move one of those terms to the other side. I'm going to move 6x. The opposite of adding 6x would be subtracting. So I'm going to subtract this whole term, 6x, from both sides. That's called the transformation principle of subtraction for equality. Alright, well, adding 6x and subtracting 6x cancels it out. So I'm left over here with negative 21. Over here, I have 33 plus 9x minus 6x. Well, we have like terms here. 9x minus 6x gives me 3x. So now I have negative 21 equals 33 plus 3x. Now we can solve and simplify this equation. First of all, I need to undo addition. So I'm going to subtract 33 from both sides. By subtracting 33 from both sides, I'm going to get negative 54 equals 3x. Now I need to divide both sides by 3. So I'm undoing multiplication. Here I get x because this cancels out. And here I get negative 18. Because I have a negative and a positive, my answer is negative. So x equals negative 18. So I use the transformation principle of subtraction for equality and the transformation principle of division for equality. And that's how you deal with equations with terms on both sides, or variables on both sides. Let's look at this example. Now this one's a little more complicated because I have the distributive principle here. So let's look at this specific example. If I have negative 6 times 4x plus 3, I need to distribute that, so I'm going to do that. So negative 6 times 4x gives me negative 24x plus negative 6 times 3 gives me negative 18. That equals, now I need to distribute this across. I need to DPS it, so I know I'm adding a negative 3. 6 times negative 4x gives me negative 24x plus 6 times negative 3 gives me negative 18. Notice I have negative 24x on both sides. So I'm going to move this one. The opposite of adding negative 24x would be subtracting negative 24x or adding 24x. This cancels out. I'm left with negative 18. But unfortunately over here, this also cancels out, and I'm left with negative 18 over here. When you have a situation like this, where your variables go away, and you're left with a true statement, this is a true statement, negative 18 equals negative 18, then all numbers, or any number, will work. So my answer would be all numbers. Or for shorthand, you can write all numbers. Let's look at another example. What if your variables go away and you're left with a false statement? Like, let's say you're left with 18 equals 17. Then you would write no solution. So in this example, we had a true statement. If at the end, when our variables went away, we were left with a not true statement or a false statement, then we would write no solution. There's no solution for that equation. Let's do one more example. 5x minus 8 equals 3 plus 7 times x minus 3. Remember, my first step is to DPS. Then I need to simplify both sides. Well, I can't simplify anything over here because they're not like terms. But over here, I have like terms, but I also have the distributive principle I need to deal with. So I'm going to rewrite my equation. 5x plus negative 8 equals 13, because I can't do anything with that yet, plus 7 times x is 7x, plus 7 times negative 3 is negative 21. Now, can I simplify anything? Well, nothing over here, but over here I do have like terms. So now I have 5x plus negative 8. I'm going to combine these like terms, which will give me negative 8 plus 7x. And that's because negative 21 and 13, one's a negative, one's a positive, I have to subtract, and my answer will be negative. So these two are equal to each other. Now, notice I have variables on each side. I need to move one of them. I'm going to move my 5x. So I'm going to subtract 5x from both sides. This gives me negative 8 equals negative 8 plus, what's 7x and negative 5x? That gives me 2x. Now I need to subtract negative 8 or add 8 to both sides. I get 0 equals 2x. I need to divide both sides by 2. Okay, when you have a situation like this, think of the opposite. What times 2 gives you 0? Well, it would be 0. So x equals 0. And that would be the solution. So whenever you have 0 on top, then your solution is 0. And think of it as a reverse multiplication problem. Now, you should be able to do this equation. So let's look at this one. If the sides of a triangle are equal, what is the perimeter of the triangle? Okay, so let's say this is an equilateral triangle. I should be able to, based on the information here in my diagram, be able to find the perimeter of this specific triangle. Now you're thinking, wait, there's nothing here, and I don't know what my variable x stands for. Well, it's easy to figure it out, because if all these sides are equal, I can write the following equation. 9x minus 14 equals 5x plus 38. Because these two sides should be equal. This is an equilateral triangle. So now I should be able to find out what x is. First step is to DPS my equation. Then I'm going to move one of these to the other side. Well, I'm going to move 5x so that I have variables on one side. I'm left with 4x plus negative 14 equals 38. I need to get rid of my 14. I'm going to add 14 to both sides because it was a negative 14. Now I'm left with 4x equals 52. I'm going to divide both sides by 4. And I'm left with x equals 13. Now be careful, you're not done yet. You need to plug 13 into one of these so that you can figure out what the perimeter is. So let's say that I use this one. 9 times 13, because I decided that x equals 13, minus 14. Right? Remember, you have to do multiplication first. So I get 117 minus 14 This gives me 103. So each side is 103. There are 3 sides, so I'm just going to multiply that by 3. And that gives me 309. And don't forget to write units. Because it's perimeter, it's not squared. So this is a good example of an application of variables on both sides. Now it's your turn, and I'd like you to complete these 4 problems.